Welcome back, and I've got a lovely experiment to show you today. This one I call the mystery magnets. And then all you do is just put your drink down on the bar and you leave it alone. I'm not sure you expected that to happen, and neither did I. So let's try and explain what's happening. Electric fields apply forces to charges. Why does putting two transparent things on top of each other do something so strange when you turn it through 90 degrees? So as you can probably see, I'm not in my classroom today. I've been shunted out. Someone else is teaching in there. So I'm in one of the prep rooms, which is a little bit echoey, but let's see how we get on. So what I've got here is two supposed magnets, but there's a catch. One of them isn't a magnet. One of them is just a piece of metal, and the other one is a genuine magnet. And the challenge I'm going to set you is to see how you could work out which one's a magnet. But before you start thinking, there's a couple of things you need to know. Firstly, one of these is a permanent magnet and the other one is made of soft iron. In other words, a material that's magnetic, but when you take it away from a magnet, it has no visible magnetic field around it. But there's one other little challenge I'm going to set you before I set you loose trying to work out which is which. So if I said to you, off you go, which one's the magnet? I know some of you would have a solution to that problem. The most well-known thing to do is to hang one on a piece of string and the poles will line up with the Earth's magnetic field and point north and south. And then you know that it is a permanent magnet. The other thing that you can do is put it near to a compass. And if one end of this repels the North Pole of the compass and the other attracts it, you know that it's a magnet. And with the soft iron, if it attracts the North Pole and still attracts the North Pole, this has to be soft iron. But I'm going to make the problem just a little bit harder. So here goes for the proper challenge. What I'd like you to do is to try and work out which one is magnetic, but you get no other things. You don't get pieces of string, you don't get other bits of metal or iron, you don't get to use the Earth's magnetic field. The only two things you can experiment with are these two objects. What would you do with them to find out which one's the magnet and which one isn't? So now's a good time to pause the video and give some thought to what you might do. Well, I wonder what you came up with. So let's try a few experiments. Perhaps you thought, well, it's obvious the magnet will have poles, so they'll stick together. And, oh, they'll stick together. So this one must be the magnet. Let's swap the places. Ah, they'll stick together, and they'll stick together. So this one's the magnet now. So that method isn't going to help us. But what it has done is it's established that they only ever attract. There is never any repulsion. So only one of these can be magnetic and the other one must just be a piece of soft iron. Right, you ready for the solution? And I really like this experiment. Okay, what you need to do is you realise there are poles and the poles are at either end. But we have no idea which of these is the magnet. And this is the clever bit. A magnet, if it's this one, will always stick to iron. Oh well, maybe it is the magnet. But let's try it on the side. Ah, it sticks to that one and draws it away. Let's swap the sides, it sticks to that one. So this one seems to always attract this piece of material. That suggests to me that this one here is the piece of iron. But let's try it the other way around. So now what we'll do is we'll put the magnet there and we'll see if this will stick to it. Well, it doesn't. It doesn't stick to it at all because it hasn't got any poles. So this one is the piece of soft iron and this one's the magnet. Let me just see if I can take it apart. And there we go. Inside, I've sellotaped together a few pieces of soft iron. This one has got a bar magnet inside. Now, this is the sort of experiment I'd set you if you came for interview or something like that, especially at a university, because you might not get it right, but that doesn't matter. If ever you're in an interview situation, talk good science. Even if your assumptions are incorrect, I'm sure the interviewer, I would say, yes, maybe, but have you thought about this? And if you can talk around the subject, you'll make yourself come across as an interesting person who knows some science. You don't have to get it right all the time, but you have to make some relevant comments. The worst thing you could do in an interview is just look at it and go, I've no idea. Okay, say some things, have a go, and then maybe correct yourself. And I do this because when I went for interview at Cambridge for my postgrad, it was the first thing they did to me. They said, we'd like to see your exam certificates to prove that you're qualified in the way you say you are. Could you just have a play with that? And they gave me a problem like this. And in fact, when I came to give the solution to the problem, I didn't get it right. Of course, that's what they wanted to happen. And then they asked me more questions and I could talk around the physics until I went, that's what's happening. So this is one to try at home. All you need to do is get a piece of iron and a magnet and you can wrap them in a bit of paper or something, cover them up so people can't tell which is which. I'm lucky that these just look like magnets. Anyway, it's a really nice puzzle. I hope you enjoyed seeing it. I'm really pleased to share it to you and I look forward to seeing you again next time.